Hello, my name is Roberto Valdovinos. I will be presenting our project, which is Mercury 2 Fulminate versus Mercury 2 Cyanate. First off, we'll get into Lewis structures and formal charge. As you can see both Lewis structures of Mercury 2 Fulminate and Mercury 2 Cyanate. There isn't really much of a difference besides the arrangement of the elements within these two, which is Fulminate and Cyanate. They are anion isomers, which basically consist of the same elements, the same number of elements, the same formal charges, some similar properties, and possibly same molecular geometry. And we'll get into more detail on the differences because they are very alike with each other. But yeah, so for formal charges, we have a negative charge, and we use fulminate ion. And the only way to find the negative charge within the fulminate is by doing the formal charge. And what we do is we get the carbon, the amount of valence electrons in each, and you can find this in the periodic table just by following down the groups from A1 to A7. We have the non-bonding. Oh, and also there's an equation down here. So it explains the formula for a formal charge. But yeah, so then it's the non-bonding. So basically the dots around, and then the bonding, which is in each line. And each line consists of 2 valence electrons. So for each line, it's times 2. So for carbon, it's C, and it has 4 valence electrons, which you can find in the periodic table. 2 non-bonding, which is these little dots, and then 6 because it has 3 bonding. So 2 times 3 is 6. Divided by 2 equals -1. And you do that for the same thing here, and you'll get -1, 1, and -1. And when you sum all these up, you'll get -1, and then that'll be the charge of fulminate. And that's how we got the ion of CNO, -1. You do the same thing for cyanate for the formal charge, and it'll be the same charge, which is a -1. So they have a similarity of charges, basically. And yeah. Okay, for resonance structures, Mercury 2 fulminate has 2 additional structures, as you can see here, and Mercury 2 cyanate has 2 additional structures, so it's the same thing. But the difference is the arrangement of elements and the formal charge of each element. That's the difference, probably. From going from left to right and left to right, it's just a different order of bonding and non-bonding valence electrons. So from C, it starts with 3, moves over to 2, but adds another non-bonding valence electrons, and then adds 2 more non-bonding valence electrons and 1 bond. And then it adds 3 bonding valence electrons, but removes 2 non-bonding, so it moves it over here, as you can see. Same thing from for cyanate. The most preferred structure is this one, obviously. And yeah. Next, we move on to stability. For Mercury 2 fulminate, it is very unstable, and that's due to its carbon having a negative charge, negative formal charge. That makes it very unstable because any molecule with a negative carbon, negative formal charge of carbon, makes it very unstable. And that right there will give you details about cyanate and why cyanate will be more stable than fulminate. So yes. After this, we try to find the fulminate sum formal charge, which is so we just find the total formal charges of each element by adding them together, as you can see here. And by adding them divided by 3, because there's 3 different structures, we get the total. And then we add them all together, so we get the sum formal charge, and it'll be -1. We do the same here, and we get -1. And then you can see that they have the same total sum formal charge, but the only thing that causes cyanate to be less unstable than fulminate is the carbon, because for cyanate cyanate never has a negative formal charge. It's always either the the nitrogen or the oxygen. So that makes a difference on stability and why fulminate is more unstable than cyanate. Okay, rule of violation. So basically, this results to the octet rule, and the only way it's violated is due to uh, the 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 total number of valence electrons being odd, or a certain element having less than or more than 8 valence electrons. Because having more or less violates the octet rule, because each element must have 8 valence electrons. And to cross off for both, they both have a total of 34 valence electrons, which is not odd and should be there. But when putting them together, both fulminate and cyanate will have a total of 16 in each. So times 2, because there's two different fulminate molecules and two different cyanate molecules. It'll be 32. So 32 subtracted by 34 will be, I mean, the mercury only has 2 valence electrons. But when it comes to sharing, they'll have a single bond here. So it'll have 2 valence electrons and 2 extra valence electrons and 2 extra valence electrons. So in total has 6 valence electrons, meaning that it will not complete its octet rule, meaning that there is a violation within the molecule. Same thing goes for mercury 2 cyanate. It has a total of 2 valence electrons and then bond with two single bonds, meaning you have 4. 2 plus 4 is 6. So that means it has less than 8 valence electrons, meaning it violates its octet rule. Okay, next on is molecular geometry and polarity. So for molecular geometry, it will be bent for both, but the difference is cyanate might have 2 bends, but we don't know that for sure due to lack of information and researching. So it's really hard to see, but many say that there is 2 bends, others say there isn't. And the 2 bends would occur with carbon. So when it's carbon and oxygen, and then oxygen with mercury, as you can see. The 2 bends would occur, one bend will occur here, and another bend will occur here in some research. Okay, and how do we get that? Is by finding the difference of electronegativity within the bond. So the reason they'll be bent in mercury and carbon is because the difference of electronegativity in both is 0.55. And then if anything falls from a range of above 0.5 and 2, it is polar. So it falls with a difference of 0.55, meaning this is polar. And with cyanate, it has 1.44 with difference of oxygen and mercury, meaning it's polar, but it also falls at 0.89 with carbon and oxygen. That means there's 2 polar effects within cyanate and not fulminate. Okay, physical and chemical properties. Mercury fulminate has physical properties. Well, they're both solids. They both have the same molar mass because they're the same elements being used in the same amount. Appearance, one is gray, powdery with crystal shape. The other one is white to gray, cubic, crystalline powder. So one will be thicker and the other won't. Melting points are different. One is 90 degrees, one is 60 degrees. Fulminate has a boiling point of 356.6 Celsius. Chemical characterization, one is they're both insoluble to water and they're both soluble to ethanol and ammonia. And that is due to mercury because mercury is solubility and insolubility. They're both flammable and fulminate is toxic. It releases toxic fumes and odor while cyanate doesn't. And they're both they both have very light reaction. So whether impact or anything like ignition will cause a very big reaction. And over time, cyanate will decompose into a gas, basically, and it'll leave off mercury behind. So that's a very big difference and very interesting, in my opinion. Now, at the end will be a YouTube video. I will be posting this link as I post the other YouTube link. It is basically just Mythbusters trying to mythbust this Mercury 2 fulminate because in the show Breaking Bad, the main character uses it as an escape route. So he basically throws it on the ground and it causes a big explosion for him to make a getaway. And that's where Mercury 2 fulminate gets most of its like fame from. And yeah, it was pretty awesome. I really enjoyed it. But overall, that does conclude the PowerPoint. And thank you very much for listening and watching.